Hey, welcome to Models and Agents, episode 19. It's March 23rd, 2026, new week in AI. And if last week was anything to go by, buckle up. Let's get into it. TrustFlow introduces topic-aware vector reputation for multi-agent systems, replacing scalar scores with queryable multidimensional vectors. This one feels like a genuinely important step forward. Today's arXiv drop is packed with multi-agent research. We're seeing new frameworks for reputation propagation, co-evolutionary prompt optimization, group-based communication topologies, and long-horizon agent training. The most immediately practical releases are Helix for joint question prompt optimization and GoAgent for explicit group-aware topologies. Developers building agent ecosystems should pay close attention to TrustFlow's resistance to common attacks and the substantial gains shown in long-horizon web tasks. Let's start with the top story. TrustFlow introduces a reputation propagation algorithm that assigns each software agent a multidimensional reputation vector rather than a scalar score. Instead of one trust number, every agent gets a vector that captures expertise across different topics. Reputation propagates through an interaction graph using topic-gated transfer operators modulated by content embeddings. The math guarantees convergence thanks to the contraction mapping theorem via a family of Lipschitz-1 operators and composable information theoretic gates. On a 50-agent, 8-domain benchmark, it achieves up to 98% multi-label precision at 5 on dense graphs and 78% on sparse ones. Even under attack, it holds up remarkably well. It resists Sybil attacks, reputation laundering, and vote rings with, at most, a 4 percentage point precision drop. Unlike PageRank or topic-sensitive PageRank, TrustFlow produces vector reputations that are directly queryable by dot product in the same embedding space as user queries. This means you can ask an agent, "How trustworthy are you on this specific topic?" with a simple similarity lookup. For developers building production multi-agent ecosystems, this is a big deal. It gives you much more nuanced trust decisions instead of blunt yes or no trust scores. The work provides a solid foundation for reputation systems that actually understand topical expertise. Now let's look at some model updates that caught my eye. First up is Helix, a dual helix co-evolutionary multi-agent system for prompt optimization. Helix jointly optimizes both question reformulation and prompt instructions at the same time. It uses a 3-stage co-evolutionary framework with planner-guided decomposition, dual-track agent critique, and strategy-driven question generation. This directly fixes a limitation in existing automated prompt optimization methods that treat user questions as fixed and immutable. The results are solid, up to 3.95% performance improvements across 12 benchmarks against 6 strong baselines. It also maintains favorable optimization efficiency, which is important. If you're working on agent reliability where prompt quality and query clarity are interdependent, you should test Helix. Next, we have a sub-goal-driven framework for improving long-horizon LLM agents. This combines inference-time sub-goal decomposition using proprietary models with Myra, a milestone-based reinforcement learning training method. Myra supplies dense rewards during training instead of sparse success or failure signals. The gains are impressive. It lifts Gemini by about 10% absolute success rate on Web Arena Lite. Even more striking, it boosts open-source Gemma 3 to 12B from 6.4% to 43.0% success rate. That pushes it past GPT-4 Turbo at 17.6% and GPT-4o at 13.9%, and even beats the prior open SOTA WebRL at 38.4%. This is one of the clearest demonstrations yet that explicit planning plus milestone rewards can close the long-horizon gap. Teams building browser or OS agents should definitely evaluate the Myra approach. There's also a sobering paper titled, "Is Your LLM as a Recommender Agent Trustable?" The authors introduce Bias Rec Bench across paper review, e-commerce, and job recruitment domains. Even state-of-the-art models like Gemini 2.53 Pro, GPT-4o, and DeepSeek R1 frequently succumb to injected contextual biases. This happens even though the models can correctly identify the ground truth when biases aren't present. The benchmark uses a calibrated quality margin synthesis pipeline to surface these vulnerabilities. It exposes a critical reliability bottleneck for high-stakes agentic recommendation workflows. We clearly still need specialized alignment for recommender agents. On the agent and tool side, GoAgent brings a fresh approach to communication topology generation. GoAgent treats collaborative groups as atomic units rather than individual agents. It uses an LLM to enumerate task-relevant candidate groups, then auto-regressively selects and connects them. A conditional information bottleneck compresses intergroup communication to keep things efficient. The results are strong. 93.84% average accuracy across 6 benchmarks while reducing token consumption by about 17%. This explicit group modeling outperforms node-centric topology methods that let structure emerge implicitly. If you're coordinating more than 5 agents on complex tasks, the group-centric approach in GoAgent is worth experimenting with. On a more concerning note, researchers demonstrated Clawworm, the first self-propagating attacks across LLM agent ecosystems. They targeted the OpenClaw platform, which has over 40,000 active instances. The worm achieved persistent configuration hijacking, payload execution on reboot, and multi-hop propagation from a single message. It reached a 64.5% success rate across 1,800 trials on 4 different LLM backends. The work includes responsible disclosure and carefully analyzes architectural root causes at each trust boundary. This shows that execution-level filtering is simply not enough when skill supply chains remain vulnerable. Now let's cover some practical and community developments. GT Space introduces heterogeneous collaborative perception with a ground truth feature space. It creates a common feature space from ground truth labels so heterogeneous agents with different sensors or architectures only need a single adapter module instead of pairwise interpreters. A contrastive loss fusion network handles diverse modality combinations. It outperforms baselines on OPV2V, V2X set, and the real-world R. Cooper datasets. Code is promised soon. Autonomous driving and robotics teams facing heterogeneous fleets should watch for the GT Space release. There's also Indoor R2X, an indoor robot-to-everything coordination framework with LLM-driven planning. It integrates mobile robots with existing indoor IoT sensors to build a global semantic state, reducing redundant exploration. The benchmark and simulation framework enables LLM-based high-level coordination. It provides configurable environments for evaluating semantic collaboration strategies. Experiments show that IoT augmented modeling improves both efficiency and reliability. Practitioners building indoor multi-robot systems now have a standardized way to test R2X approaches. Okay, let's pop the hood on this reputation vectors idea because it's one of the more elegant pieces of engineering in today's drop. Everyone talks about trust in multi-agent systems as if it's a single number you can page rank. In practice, scalar reputation collapses critical context and makes topical expertise impossible to query directly. TrustFlow replaces the scalar with a vector in the same embedding space as user queries. This turns reputation into a simple dot product lookup, which is elegant and computationally cheap at inference time. The key engineering insight is the topic-gated transfer operators that modulate each graph edge by the content embedding of the interaction. These operators are carefully designed to be Lipschitz 1, guaranteeing convergence via the contraction mapping theorem regardless of graph density. The composable information theoretic gates further prevent reputation laundering by controlling information flow per topic. On sparse graphs, the method still reaches 78% precision at 5, showing the vector approach scales where scalar methods degrade. The gotcha that bites most teams is assuming uniform propagation works across domains. Once you have more than 3 or 4 distinct topics, scalar methods lose too much signal, so use vector reputation when your agents must demonstrate different expertise per query. Stick with scalar only for very narrow single-domain swarms. Now for things you should actually try this week. Try the Mira milestone-based RL approach on your long-horizon web or browser agents. The jump from 6.4% to 43% on Gemma 3 to 12b is too large to ignore. Experiment with GoAgent's group-centric topology generation if you're coordinating more than 5 agents on complex tasks. The 17% token reduction is immediately valuable. Test your current LLM as recommender pipeline against simple contextual biases using the bias-rec-bench methodology. You may be surprised how easily high-stakes recommendations get hacked. Explore TrustFlow-style vector reputation for any multi-agent system where topical trust matters. The dot product queryability makes it practical to integrate today, and download the upcoming GT Space code when it's released and evaluate it against your heterogeneous sensor fusion setup. On the horizon, expect more agent topology and reputation papers building directly on GoAgent and TrustFlow in the coming weeks. Watch for the public release of clawworm defense recommendations once responsible disclosure concludes. Fin reasoning and geo-challenge benchmarks are likely to spawn improved financial and geometric reasoning models quickly. Continued progress on hybrid real-time plus asynchronous agent engines will influence production conversational systems. Before we go, tomorrow keep an eye on further developments around vector-based reputation systems as the community starts experimenting with TrustFlow. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.